Felipe Segovia, en el que la ciencia, la investigación y vosotros, los investigadores, sois los verdaderos protagonistas. Dear attendees and distinguished members of the SEK Scientific and Learning Community, it is an honor for me to welcome you to the second edition of the Scientific Congress, organized by the Felipe Segovia Foundation, in which science, research, and you, the researchers, are the real protagonists. It is research that drives advances, allowing, for example, this Congress to be accessible from different geographical locations such as Madrid, Cataluña, Pontevedra, Almería, Dublín, Qatar, Bahrain, either in person or through our virtual platform designed by the UCJC technology team for this purpose. Comenzaré mi breve introducción afirmando que el conocimiento es siempre un tesoro, pero la práctica de lo compartido lo hace invaluable. Durante meses habéis formulado hipótesis, habéis diseñado y realizado diversos experimentos que habéis registrado en rigurosos informes. Sin embargo, como sabéis, es importante recordar que el trabajo científico no se limita al laboratorio. La divulgación de investigación constituye una parte esencial de la labor de un científico, ya sea a través de publicaciones o mediante la presentación de ponencias en congresos similares a estos. Son estas actividades de divulgación las que permiten a los científicos compartir y difundir sus hallazgos, fomentando así el avance colectivo del conocimiento. Se pone de manifiesto de este modo el valor de impulsar competencias tales como la comunicación eficaz, el rigor investigador o el aprendizaje permanente, todas ellas integradas en las diferentes transformaciones que forman parte de nuestro perfil competencial de la institución educativa SEK. Knowledge is always a treasure, but the practice of sharing it makes it invaluable. As you know, scientific work is not limited at the laboratory. Dissemination of research and results is essential and is an essential part of scientists' work, whether through publications or by presenting papers and communication at congresses, similar to this one. These outreach activities allow scientists to share and disseminate their findings, thus fostering the collective advancement of knowledge. This highlights the value of promoting competencies such as effective communication, research, and lifelong learning, which are integrated into the different transformations that form part of our competence profile at the SEK Education Group. Quiero transmitir mi más sincero agradecimiento a todos los implicados en la organización de este congreso, docentes, personal administrativo y logístico, que han brindado su apoyo. Su compromiso y dedicación han hecho posible este encuentro, que sin duda tendrá un impacto significativo en el aprendizaje de nuestra comunidad. I would like to thank everyone involved in the organization of this scientific congress, teachers, administrative staff, and logistics, who have given their support. Their commitment and dedication have made this meeting possible, which will have a significant impact on learning in our community. Thank you very much. Muchas gracias.
Well, thank you, Elvira, for your wonderful words. And I would like to start with a quote that says, "What you do makes a difference, and you have to decide what kind of difference you want to make." This quote by Jane Goodall is brilliant evidence that highlights the importance on how we focus our ideas.
Don Javier Presol, Director of Felipe Segovia Foundation, Doña Maricruz Lagar, General Director of SEK Schools, esteemed public and colleagues, we're Claudia Serna and Susana Varela, TP1 and First of Bachillerato students from SEK Ciudad del Campo and El Castillo, and we're very excited to be here, and we come before you to accompany you in the second SEK Scientific Congress.
Since I was a kid, nature has been the one that caught my eye and led me into a field of curiosity, science, and research, and helped me realize that the path that I needed to follow is one that includes science in it, and I haven't changed my mind since. Becoming a veterinarian has always been the way I have seen myself in the future, as I find it so thrilling to help the furballs I find so dear to me. Yet, I didn't limit myself into one single aspect of science, as I am a person who enjoys experiencing new things. For that reason, I participated in the second Battalions team, where my team created a pen in order to help people with Alzheimer, or then as a JPL project that shows that space is another subject that really amazes me.
Maybe some of you recognize me from last year, because I had the pleasure of hosting this event too. However, the reason why I'm here today is quite different. Last year, as the winner of the Felipe Segovia Award, I had the honor of presenting the first edition of a project that was just taking shape for the first time. This year, to show my gratitude to the Fundación Felipe Segovia, I decided that my scholarships project was going to be to help with the organization of this year's edition of the Scientific Congress. I've been behind the scenes. I've seen how much work everyone has put into this event, all the meetings and effort it takes to carry out a Congress on this scale, and I wanted to be a part of that. However, the true reason why I'm here both years is my passion for science. Since I can remember, I've been the type of kid who always asked why in school about everything. I wanted to know how clocks work, why classes make one see better, and why do rainbows exist. I decided that the path I wanted to follow was engineering. This fundamental science provides the answer to why does everything work the way they do. So in order to satisfy my intellectual curiosity, I wanted to pursue a career on that theme.
Therefore, we have come to the realization that what really joins and binds the people in this room is science. When we grow up, we want to go into science as we imagine many of you do too, maybe as a biologist, mathematician, or even as an astrophysicist. Who knows what our science field future will look like? As we are able to see, the thing that ties us all together is our shared interest for research, innovation, and creativity within solving problems we may find in our future.
It doesn't matter the career path you want to follow, even if you don't know what you want to do yet. Something that unites us all that we're in here is the curiosity to keep on asking questions about everything that surrounds us. Not only science related, but many fields in the humanities, they use the scientific method too to prove a theory right or wrong. During this second scientific congress, we have come together to present the findings of rigorous research you have done over the year and share the conclusions you have drawn from this in this scientific community we have built.
We hope that everyone participating in this event, either as audience, speaker, online, or in person, will enjoy the second scientific congress that we have the pleasure of presenting. Thank you so much.
Now we're going to give the word to Dr. Vicente Timón Sabiniero. Dr. Vicente Timón is a thesis research scientist in Madrid, specializing in quantum physics and materials. Having worked in various institutions, he has authored over 70 scientific articles and is renowned from his work in science communication, including a radio program and workshops for students. In his talk, he will share his experience regarding the true calling for science. Let's give him a warm welcome.
Hello, everybody. Good morning. Yes, it's me, Dr. Vicente Timón. Soy el Dr. Vicente Timón. Trabajo aquí en el Consejo Superior de Investigaciones Científicas. Y dentro de lo que es mi parte como investigador, pues bueno, también tengo una parte divulgativa. I am also a communication scientist. I'm going to tell you a tale, a real history, because I am a scientist. Yes, me. Okay, I am not from Madrid. I am from a region called Extremadura. You know, Extremadura has been near a poor region in the past. Now it's a so beautiful region. I advise you to travel to this part of Spain because it's so unknown and so beautiful. Okay, I come from here. I was born here in the Comarca de la Vera, close where Charles V, Carlos V died, our very great emperor. Well, when you born, what the childs, the babies do when they born? They observe, no? They look at the world. They have curiosities, but it is time somebody don't remember, no? When you have 1, 2, 3, 4 months, 1 year, 2 years. But if you ask your mother, your father, probably they say, yes, you was a curious boy because you did something, you beat a piece of thing or you fall down from the bed, etc. Why? Because the human being has curiosity. Why this curiosity? The human being wants to know. Well, me, in this small village, I imagine I did the same. My father and my mother told me, yes. Well, we grow. The curiosity started to be more in advance. I was living in a small village, I told you. Then, in my time, there was only 2 options. Only 2 options. Well, there was only one option, football. My friends, all of them, Vicente, come on to play football. Or come on sometimes to go to the countryside to get birds, to get some animals, because it was a friendly environment. But in TV, I saw one of the main persons that I like a lot. One series called Cosmos from Carl Sagan. My friends, Vicente, what are you doing watching Carl Sagan in TV, in black and white TV, about the stars, etc.? No, come to play football. I said, no, I like stars. Because I was in the night also observing stars, also observing the sky, etc. No, I prefer this. Also, in this time, I remember Star Trek on TV also. Wow. Carl Sagan said how the universe, how the star is made, and also Star Trek. They travel, fight, etc. It's incredible, the universe. But we don't know so much about the universe. I then decided, okay, I would like to know more about the universe. And then my friend said, Vicente, you are crazy. You are a good football player. Yes, I play football. I was not so bad football player, but I decided, no. I prefer to follow Carl Sagan or Star Trek. Well, I follow Carl Sagan, but one curious thing. In a small village of 1,500 people, in the library comes this good journal, Scientific American, Investigación y Ciencia. The librarian told me the first day I saw this journal, what are you doing watching this? I told her, I like. But you understand, you are only 6 or 7 years old. She told my father and my mother, your son is crazy. He's reading one scientific journal, nobody read in the village. It's only, I don't know why, stay there. It's because in my county, probably the government decided to send this journal to the libraries, but okay. Wow, good. I learned a lot of things. We are growing, then discoveries. My village is a very beautiful village. It has in the middle of the street small canales, and we like to play with the paper ships. Most of you have done paper ships. I decided, because I was curious, to start to play with my friends to do races of paper ships on these channels. I lost the first races, and then I decided, no, Vicente, you should think which is the best ships. I developed by myself 6, 7, 8 years the fastest ship nobody has done anymore before in the village, and I won the race. Also, I designed one airplane without engine, because no was opportunity to put engine, etc. Also, in the school, it was something that was exported to several schools in my areas. I designed some comets because I like the art of flying for me was, wow, I need to do that. And one important in my life was when my father and my mother, and my family said, this boy is crazy. Okay, they give me as a birthday present one book about Leonardo da Vinci. Astonishing. You see, read Leonardo da Vinci, read his book. Some in my family argue against my father because they said, how you give a present one child with 7, 8 years, one complex book about Leonardo da Vinci? I read in 2, 3 weeks, I learned the most of the things that Leonardo da Vinci did. Also, you know, TVs, etc. I invited one machine to cut the grass because my father has a big garden, and then for me, it was so tired always pushing this machine. I invented another device to do yogurt because I like yogurt. Pues okay, I decided to invite this. Imagine, okay, look to the bicycle. Well, then it was clear. Not so much football. I was playing football also in this time, but not so much. Okay. I need to continue my studies because I wanted to overall to analyze the skies, the universe. In my time was Bubco and Bachillerato. What the most of you are doing, or no? It's hard, eh? You need to study. Well, I remember physics, I remember mathematics, etc. I was with a fellow because in my area there was no institute, and then I was in the fellows in the Colegio Claret de Don Benito, the Claret congregation. But when you finish, then was yeah the real decision. I wanted to be a scientist, but okay, I got a very good high level, and then before to go to the university. Then in my family, they say, it is very clever, very intelligent boy, doctor. He should be a doctor. Medicine, because the doctor, you know, in this country, of course, you are a doctor, it is so important. I say all my family, no, physics, astrophysics. Why the stars? Why you are not a doctor if you have enough level? I don't remember, in this time was, I got 8.7, and to go to the medicine was then so difficult, eh? Of course. If some of you want to go to do medicine, please go, okay? But if some of you want to become a scientist, please become a scientist. Well, I decided physics. But in the bachillerato for me was not so good because I didn't study nothing about the stars, about the universe. I said, okay, I want to be a scientist to study the universe, but no. Well, physics science. Where? In my region, in Extremadura University, in Badajoz. Well, physics science, not so bad, not so bad. I remember a very hard time the first 2 years. Because why? The mathematics. Nobody advised me that the physics needs so much mathematics. It's horrible. The first 2 years, Cauchy, Lagrange, L'Hopital. I remember L'Hopital. Oh, the rule of the L'Hopital. Oh my God, to learn all of these things. I said, the stars, where are the stars? Oh my God. But okay, I passed. I passed with a very good level. The only thing is that, okay, continued without to study the universe, the star, what I wanted since I was a child. Well, I am a physicist, I am a scientist. In my region, you know, not so much opportunities. If you finish one high level, okay, go to be a teacher, one of your teachers. It was it's quite a good work, no? Bueno, okay, pues try to research in Spain. Not so easy, but it's possible to research in Spain. Well, then I was quite lucky because the Universidad de Extremadura then trusted me and said me, okay, come here to research. But the most important was the CSIC offered me one position here, the place where I am now. And then I come from the Extremadura to Madrid. To study what? Clays. Yes, clays. You say, but you wanted to do universe, to research in universe, etc. Clays. Why? Because sometimes when you want to become a scientist, you know, the ways differ. Usually, you go for the way that you want. But in my case, they offer me, Vicente, if you want to come here to do your PhD, should be in clays. Not to do pots, okay? Clays are very good material. I am not going to explain. If some of you want to know more what I have done about clays, etc., I have a web page, and you can search so many publications that are very useful about clays. Okay, I did a very good thesis about clays here. I discovered a lot of things about clays. I am so proud about it. I enjoy, I like the research in clays, but nothing about stars, about planets, etc. Well, if you want to become a good scientist, after your PhD, you should go outside to do a doctorate. Well, postdoc. I say, well, it is my opportunity to, at last, research in universe in stars. No. In Durham, the University of Durham, of the United Kingdom, they offer me, well, I apply for 2 fellows. There are 2 possibilities, to get 1 fellow from the Spanish government and another fellow from this country's government. Then I applied for these 2. The first fellow approved was the English one, was more money, was more all, better condition, then I decided this one. The only problem was this, okay? The subject that they decide, not my subject. Because I applied from one here at the Spanish government to go outside, it was just to go to the United Kingdom, to the King College in astrophysics, but come later and, well, okay, I decided to get the English one. I enjoy a lot. I research in a very good subject. I don't know if some of you know, well, here we are now surrounded by LEDs. These diodes that emit light in overall in green, red, and blue. This LED, in this time, was in development. Nobody has been able to build this in a reasonable price. Okay, we discovered the reason because it happens, and was a very good work. I received 1 award and all the team, and since this time, with our research, the LED was implementing across the world. You see, in cars, in traffic, in lights in the cities, etc. It was because this work in Physical Review B and in, well, it was in Journal of Condensed Matter the selected paper of the year because it was so useful. They couldn't implement this technology to the humanity. Okay, here, did by scientists. We have a skin, etc. But okay, no planet, no stars. Yeah, I say, well, when you do a PhD postdoc, you are a good scientist. You ya can wear, I don't know how it's in English, no sé cómo se dice bata, ahora mismo no me acuerdo. Ya te puedes poner la bata bien, como un campeón. Pues ya eres un científico o una científica. It doesn't stop. Sorry, it doesn't stop. You need to research. You need to search a place where to work, a good laboratory. If you have a good curriculum, it's not so difficult to get a good laboratory. Of course, 30 years, more than 30 years. Some of us, in my case, was the same. We have family, etc. You need to think in money because you need to grow your family, or no? If you're a scientist, you should travel a lot. Need to be friend with some of your colleagues because it's the same in the human relationships. We sometimes are more near than one people than another people, etc. And to be a lot of ideas, try to develop these ideas and start to the worst thing of to be scientist. I say here the bureaucracy, o sea, la burocracia. They deal with the papers, the projects, etc., etc. And yes, publish as much as possible. But I advise you, yeah, in this time of your life, you enjoy how a scientist because you do what you want. You are curious, you are generating knowledge that nobody has done in the planet, etc. It's incredible. And you wear the bata. Well, what I am doing now, because I am a scientist, because I work close here in the Instituto de Estructura de la Materia, and I work in the Departamento de Física Molecular Physics department. These are the lines that we have. I am in the group of the atmospheric system astrophysics. You see, yeah, now I am going to explain you. Yes, I am doing astrophysics. Also observing, but not astrophysics. I'm going to explain you a little bit what astrophysics I do. Also plasmas. Plasma is so important, the fourth stage of the matter, etc. Yes, we have plasmas and these very complex laboratories. Okay. Yes, so happy. I'm doing science. So hard, you see. When I started in my small village, and now yeah, close to more than 50 years, etc. So happy doing this. I am doing astrophysics now. Yeah, I am doing, for example, laboratory astrophysics. Why? I explain briefly. Because the people that observe the universe get overall information by the electromagnetic radiation. This electromagnetic radiation, this spectra, you should compare with something, or no? If, for example, in some nebulae, there are, for example, urea. Urea is a molecule we have studied recently. How you know that in this part is present, there is a urea? Because you have done in the laboratory, you have registered this infrared spectra at this condition. Yes, we have a cold chamber. We call the samples to 10 kelvins with the very low pressure, 10 minus 6 minus 8 millibars, etc. It is a plasma where we do the discharge, cold plasma, no hot plasma. Hot plasma is the sun. We don't have a sun. So good. Also, when you are a good scientist, you can do what you want. Claro, if the authorities, etc., they leave you because you need money to do all of these things. But okay, more or less I have money, etc. One thing I am researching now is this in Venus. You know, in Venus there is a phosphine, or there is a very big controversy now in the astrophysics community because some observations they say, yes, there are phosphine, and other observations say there are not phosphine. Yes, I don't know if there are or no phosphine. It's not clear the spectra. Okay, we are doing in the laboratory some analysis and also some modeling to see if they fix with the astrophysics observation. And I explained, for example, something crazy. One of my students from the university come to do practice. She was Chinese, and she said, Vicente, I learned what you wanted that I learned. I would like to do something more. Yeah, I told her, okay, what do you want to do? She said, no, Vicente, tell me something. I said, what you are intriguing? She told me, okay, glutamato monosódico. What? It is the salt that the Chinese people use. Okay. Why glutamato monosódico? She said, I would like to know more in deep which is here in this salt, because all the Chinese community use. I say, okay, Gema is Gema 1. I thought Gema was born here and etc. Is comes from the Chinese community here in Madrid. I say, Gema, okay, Gema, let's go to study glutamato monosódico. If we are close to publish these results, incredible work have done in practice, Gema, researching something that for her was interesting, the glutamato monosódico, the salt. It was unexplored science now. Well, I am also one European project with Maria Luisa Senen. Yes, when you get to this level, it is something quite important. You know, the atmospheric contaminant, these non-conventional molecules, nitrophenol, nitroanthracene, etc., with active carbon, trying to do mask. We got from the European Union near 1 million of euros to develop this project. An important part for all of you. More investigation. You can see my curriculum is in internet, but this part. If you are a scientist, also you can research. But it's quite important what I am doing here. Or when I went to your school in Villanueva la Cañada this year with the childs to transmit our knowledge to the younger generations, because the scientists of the future will be all of yours. Me, more or less, my career is good, but okay, I am, how would say in English, when I more or less fixed, okay? You are the scientist of the future. Pues one thing that allow the science is to become divulgar. To stay in contact with child, etc. We now recently have developed one here in la calle Serrano, this telescope to observe the stars, etc. And it's free. Once a month, you should register and go to observe the sky. You know, in Madrid it's not easy because the light on the sky. And the other thing is also important in science, or some of you probably is thinking, is this one. you are famous, you are a scientist. Some of you know, yes, the most important, hombre, which now, I tell you, for example, Carl Sagan, Hawking, Stephen Hawking. I knew him. I met with Stephen Hawking twice in my life, etc. If I am a scientist, I am able to be a famous influencer, YouTuber, Instagrammer. No? You can think in it. Okay, for example, I did one crazy work about Cooper squared. It is a very crazy material, do very stranger things. When you want to compress, the material expand, and when you want to expand, it compress. Some of you have heard to speak about no Newtonian liquids, something similar in Escuarato de Cobre. We went to Radio Nacional, Spanish TV, etc. Also with the capture of CO2 in El Periódico de Galicia, etc. And me, with some friends, etc. Here, Hector is with me. Pues we have a radio, live radio once per week in one Madrid radio, one radio program called Locucencia. It is another task that you can do if you are a scientist. I advise you, yes, there are very good influencers in science. Now in Spain, quantum fracture, for example, or this scientist, I know her from the Instituto Cajal, I don't remember the name of Patricia Trenzanos, Anthroporama, I believe it is. But it's not so easy. If you are an influencer in YouTube, it's not so easy to research, etc. Because this YouTuber, etc. They get a lot of time. Pues more or less, that's it. We are not so famous, but in our world, we are known. And yes, we pass to the history because our discoveries. I advise you my discoveries about lead. I have now, but I can't speak, but I am quite close to do now here in the CSIC, and probably in the next 2 or 3 months will appear in the news media, another very good communication. We are close to submit one manuscript to Nature journal about, okay? I only tell you. But then if you see if it is clear in Nature accept our research, you will see, okay, it was this crazy scientist that told us about this in the second SEK scientific meeting. To finish, it's good to become a scientist. For me, for Vicente Timón, yes. For yours, it depends of yours. But I explain you what I do. How scientists, one normal scientist grown from one part of Spain, very normal, etc., etc. If you want to do all of these things that I do, and more, of course, more. It is possible to do more things. Okay, be scientist. Then I tell, it is a sentence made by me, I tell in Spanish, bueno, I can translate to English, o sea que, pero sí que os digo que independientemente de que os dediquéis o no a la ciencia, es verdad, nunca dejéis de ser curiosos y de preguntaros el porqué de todo, sin ser vosotros mismos. In English, more or less, if you will be, you are going to dedicate to the science or no, please keep your curiosity, ask for all, being yourself. Gracias a la institución SEK y a todos vosotros. Thank you.
Well, thank you, Dr. Vicente Timón, for your inspiring words. And we wanted to give you this special detail in order for your contribution in this Congress. And thank you so much.
And hope is needed. More scientists, male and female, because the human knowledge, wow, is incredible. Thank you very much.
Okay, so now we will proceed and let our fellow students take the word from here and explain to us their exciting projects. We will hear from SEK Alborán, Bahrain, Qatar, and El Castillo in that order. But before giving the word to the speakers, we wanted to introduce a little challenge to the audience.
Science is not only based on rigorous research and making constant breakthroughs and discoveries. There is also a fundamental part, which is the dissemination of the data, being able of presenting your findings to others, which requires effective communication, which is part of the SEK profile inside the relational transformation. However, it doesn't stop there, because communication has two ways. There's a part of expressing and communicating successfully, but also a part of listening and comprehending what other people are saying. We have created forms that you can access through a link if you're online or by scanning the QR codes if you're in person. And in that forms, you will find a compilation of questions about the presentations that you will see here today that you guys can answer to participate in this exchange of information to achieve effective communication. This way, we can give recognition to the best listeners of the room. And one last surprise, at the end of the survey, you will find a final question in which you, as an audience, will be choosing who you think communicated better their findings. Because as I mentioned previously, it doesn't matter if you discover a revolutionary finding, but you must know how to disseminate and explain yourself to be valuable. Now, I give the word to SEK Alborán. Good luck, guys.
Good morning, my name is Pablo. I'm from SEK Alborán, a student of MYP5, and today I'm here to tell you about my project of osmosis in plant cells. Firstly, I would like to introduce the topic by explaining what osmosis really is. Osmosis is the movement of water, of the solvents such as water molecules, across a semi-permeable membrane that only allows certain substances to pass through. This movement is a type of passive diffusion, which means that it requires no energy and it will always go from a region of lower solid concentration, which is called hypotonic, to a higher concentration solution, which is hypertonic. In plant cells, osmosis can lead to these two phenomena, turgidity and plasmolysis. Turgidity is when the vacuole of a plant cell swells of water and gets bigger, whereas plasmolysis is when the vacuole loses water and the cell shrinks. Osmosis is crucial in terms of agriculture, since the salinity of the soil can strongly affect the absorption of water of plants if the environmental solution is hypertonic. Osmolarity regulation is fundamental to maintain a correct development, growth, and productivity of plants. With that in mind, I established an hypothesis in order to study how different salt concentrations can affect on the weight and size of different potato cylinders. Therefore, the independent variable was the salt concentration of water, the dependent variable was the weight and size of the potato cylinders, and some control variables were the amount of water in each trial, the potato sum of exposure to the salty solution, and the room conditions. In this slide, we can see the experimental method that I followed in order to test the hypothesis. Summarizing, I took 25 beakers and I grouped them by groups of 5. Then in each of them, I poured 100 milliliters of tap water, and then I increasingly added 5 grams of salt per group. In the first group, I added 0 grams of salt, then in the following one, 5 grams, then 10, 15, and lastly 20. Afterwards, with an apple corer, I cut out potato cylinders from a great number of potatoes, and then I dipped in 2 potato cylinders in each beaker. Finally, I waited for 30, 180, and 240 minutes to check the results. After the methods, these are the results obtained, and I also calculated the averages of each group of beakers. Then I decided to calculate the percent of change between the initial and final value from each group of beakers. With this, it can clearly be seen that there exists a decreasing trend in the results. Finally, to prove this decreasing trend, I decided to calculate Pearson's correlation coefficient that shows whether 2 variables has a strong correlation or not. This coefficient goes in a scale from -1 to 1, passing through 0. -1 and 1 represent a perfect, negative, and positive correlation respectively, whereas 0 represents a null correlation. After recalculations, I got a result of -0.55, which represents a moderate negative correlation. Then, with all the results acquired, I reached the conclusion that these results support the hypothesis, since there exists a negative trend that shows that as the salt concentration in water increases, then the weight and size of potatoes decrease. Then I evaluated the method, taking into consideration some strengths and limitations. Some of the strengths of this method were its exuberant collection of data and its ease to be replicated. In contrast, the limitations found were that the salt increments interval were too high to observe a detailed tendency in the results, and also the measurement uncertainties due to the human's lack of precision. And to end this presentation, I would like to make mention of the competences and skills applied during this project. Firstly, there is investigative rigor, since during the project it was necessary to investigate and inquire in order to understand how osmosis occurs. This also was helpful later to establish a well-founded hypothesis. Secondly, the efficient communication, since throughout the laboratory report, it was crucial to apply scientific language to display the content, as well as communicate efficiently and coherently. The third point was critical thinking, since during the laboratory practical, it was required to apply activities such as analyze the data and draw conclusions. These processes encourage critical thinking skills such as evaluation, analysis, and the calculus. And finally, the fourth last point was the self-regulation, since in order to successfully complete the project, it was required to have a proper organization and time management skills. That was it.
Buenos días, mi nombre es María Eugenia y hoy estoy aquí junto con mi compañera Rocío. Ambas somos estudiantes de PAI 5 y hoy vamos a exponer nuestro proyecto acerca de energía a partir de biomasa. Hemos querido desarrollar un proyecto que se centre en obtener energía limpia a partir de dos fuentes renovables, el hueso de aceituna y la cáscara de almendra. Se busca determinar cuál de las dos opciones es más adecuada dependiendo de diferentes situaciones o contextos. Además, se debe tener en cuenta la disponibilidad local de cada uno de estos recursos. Nuestra investigación se relaciona con el Objetivo de Desarrollo Sostenible número 7, energía asequible y no contaminante. También hemos aplicado la habilidad impacto ecosistémico, ya que ambos tipos de biomasa son combustibles renovables y su uso impulsa el desarrollo sostenible de los recursos.
Nuestra pregunta de investigación es: ¿cómo afecta el tipo de biomasa, en nuestro caso la cáscara de almendra o hueso de aceituna, a la cantidad de energía calorífica producida por el método de la combustión? Hemos elegido estas variables independientes debido a que en España las podemos encontrar en grandes cantidades y ambas fuentes de energía se utilizan mucho para obtener energía a partir de materia orgánica. Además de que tienen unas propiedades que favorecen este tipo de combustión, como en el caso de la cáscara de almendra, un bajo porcentaje de humedad, o por otro lado, en el hueso de aceituna, dispone de una gran capacidad calorífica. Al principio del proyecto, mi compañera María Eugenia y yo supusimos que el uso del hueso de aceituna como biomasa, en lugar de la cáscara de almendra, proporcionaría una mayor cantidad de energía calorífica generada. Esta hipótesis se basa en factores claves, como que el hueso de aceituna tiene una mayor densidad que la cáscara de almendra. Esto sugiere que una mayor cantidad de material combustible por unidad de volumen. Además, que el contenido de carbono en el hueso de aceituna es superior a en la cáscara de almendra y el carbono es un componente fundamental en la generación de calor. Además, por último, la capacidad de la retención de calor del hueso de aceituna es superior al de la almendra.
Antes de que mi compañera exponga la reacción química que hemos escogido, debo explicar que todo el proyecto se ha planteado a nivel teórico, puesto que para realizar la combustión de ambas biomasas se necesitan hornos industriales que alcancen temperaturas muy elevadas. Además de esto, el hueso de aceituna que hubiera sido idóneo es el que resulta de la producción de aceite de oliva una vez que se ha deshuesado el orujo en la extractora o en la almazara. Y nosotras hemos utilizado hueso de aceituna de mesa. Por tanto, explicaremos cómo se debería hacer la combustión de cáscara de almendra y de hueso de aceituna a nivel industrial para obtener energía renovable.
El proceso de la combustión es una reacción química exotérmica en la que se liberan tanto energía calorífica como lumínica. Para llegar a obtener la energía eléctrica a partir de la energía calorífica obtenida anteriormente con la combustión, utilizaríamos un proceso de turbina de vapor generadoras de electricidad.
Para que nuestros datos se pudieran presentar de manera visual, empleamos cantidades pequeñas, aunque en fábricas se utilicen grandes toneladas de los residuos. Utilizamos la primera fórmula que se adjunta para calcular la cantidad de energía calorífica producida a partir de 1 kilogramo de cada biomasa. A continuación se planteó de forma teórica la fórmula que se utilizaría para calcular la energía eléctrica, que es el coeficiente de Seebeck. Se trata de una propiedad que mide la capacidad de un material para convertir la diferencia de temperatura en electricidad o viceversa. Finalmente, realizamos una extrapolación con el fin de calcular las cantidades empleadas en el ámbito industrial para obtener nuestros resultados definitivos. Desde el punto de vista energético, en el gráfico se puede apreciar que los huesos de aceituna suministran más energía calorífica que la cáscara de almendra. A pesar de que la cáscara de almendra tenga mayor capacidad calorífica, la temperatura que alcanza el hueso de aceituna durante su combustión es mayor y, por tanto, desprenderá más energía al ser quemado.
Tras realizar el experimento, podemos verificar que nuestra hipótesis está respaldada por los datos. Sin embargo, la elección entre huesos de aceituna y cáscara de almendra para la producción de calor es muy importante considerar el contexto específico en el que se aplicará, ya que ambos materiales tienen desventajas y ventajas. Si el objetivo principal es maximizar la generación de energía calorífica, los huesos de aceituna podrían ser preferibles, debido a su mayor densidad y contenido de carbono en los huesos. Por otro lado, si priorizamos la reducción de emisiones de CO2 o la minimización del costo en la adquisición del material, las cáscaras de almendra podrían ser preferibles, ya que su disponibilidad y costo potencialmente bajos podrían ser más atractivas. Muchas gracias por vuestra atención.
Well, thank you, SEK Alborán. Now we will continue with SEK Bahrain, but first we will remember a few things.
It's very important that you fill the forms that we've created so that you guys can interact with the presentations and with all the information that it's been presented to you guys. It's an opportunity to learn and to try to establish that knowledge that people, wonderful people and scientists are presenting to you guys. So we encourage you to fill the forms, because those that answer the most correct questions will get a recognition as the best listeners. So keep on answering the questions. Thank you.
Here's your presentation. Just have to share. Share, but then I need to open it on the other screen. Mai îndără ceva?
Okay, so our independence variable was the weight of our skateboard. The dependent variable was the distance of the bounce back, because we needed to measure that after the reaction happened. The distance traveled by the collision is constant, and the force of the skateboard before impact, we apply the same force. This is a picture of our mini skateboard, and this is the skateboard with weights on. This is our tip measure. So our observations, as predicted, the skateboard without the weight attached traveled further backwards after it had impacted the wall. Our experiment is not in a fully controlled environment, but there is a possibility that although we gave both boards a 60 centimeter long push, there may have been an imbalance due to human error in force pushing them. Furthermore, the shape and design of the glue stick makes the second skateboard less aerodynamic and more prone to air resistance, and that maybe could have changed our results. Table and statistics. And we did 6 trials, but these are the 3 more accurate ones. Without the weight bounce back, it had 15 centimeters first, and then the second trial had 7 centimeters. For the second one, we put a bit more distance, and it travels 21 centimeters after it hit the wall. But with the weight, it hit 5 centimeters. And trial 3, it was 18 centimeters without the weight and 8 centimeters with. So we calculated that the average bounce back was 18 centimeters without weight and 6.66 with weight. And we noticed that the more distance we gave the one with weight, the less it would travel afterwards. Our conclusion is objects with larger mass require an increase in velocity in order for reaction forces to yield the same result. This here shows that essentially the measuring the action reaction force is very similar to Newton's third law. This is our work cited, and thank you.
Solo leave
Slideshow. Ready.
Hello everyone, my name is Beta, and today I'm going to be presenting to you the presentation on freezing water, more specifically how the volume of water affects the rate of freezing. So first of all, let's discuss the definition of freezing. Freezing is the process in which a substance changes from a liquid to a solid state due to the removal of heat energy or cooling, and it is known by the formation of arranged molecules as a transition from a more disordered liquid phase to a more structured solid phase. So volume change during freezing. Water is one of the few substances that expands upon freezing, and as water molecules arrange themselves into a solid lattice, which is like kind of a structure, they form open spaces, resulting in an increase in volume. This expansion.
You need to share the screen again. Yeah, not share the screen. You're not sharing the screen.
Oh, then that's paused.
سجل طيب عليه من الأول.
I've started from the beginning.
Better.
Yeah. Again?
Yeah.
Okay. So freezing water. So hello everyone, my name is Beda, and today I'm going to be presenting to you my presentation on freezing water, how volume affects the rate of freezing. So what is freezing? Freezing is the process in which a substance changes from a liquid to a solid state due to the removal of heat energy. It is known by the formation of arranged molecules as a transition from a more disordered liquid phase to a structured solid phase. Water is one of the few substances that expands upon freezing, and as water molecules arrange themselves into a solid lattice structure, they form open spaces, resulting in an increase in volume. This expansion during freezing is why ice cubes float in water and why frozen pipes can burst. So, for the factors that affect freezing rates, temperature is one of them, and this diminished temperature expedite the process of freezing by decreasing the average kinetic energy of water molecules, therefore helping their subsequent arrangement into a solid structure. Surface area makes for a swifter heat transfer, which in turn accelerates the freezing process. Similarly, smaller ice cubes possessing a greater surface area to volume ratio freeze more rapidly than their larger counterparts. Agitation, the act of a stirring or movement, exposes a greater number of water molecules to the frigid environment, intensifying the freezing rate through enhanced heat exchange opportunities. So for our experiment/analysis, we have had two tries, one with a 50 ml container of water and one with a 100 ml container of water. As you can see, the 50 ml container of water had a 1.6 hour time limit to freeze, whilst the 100 ml had 2.5 hours to freeze. And we have tried the same two containers multiple times, and we have found out that it is between 1 to 3 hours for the 50 ml container to freeze and 2 to 4 hours for the 100 ml container to freeze. So because of this, we can now see that the larger the amount of water freezing, the more time it will take for the water to actually freeze. This is our poster. Okay, and these are our control variables, water in the container. The dependent variables are time, of course, and our independent variables are the amount of water. So in conclusion, water has a unique behavior when it freezes, expanding in volume instead of contracting like most substances. The freezing rate of water is influenced by factors such as temperature, surface area, and agitation, as these are the factors that affect the freezing rate. And understanding this phenomena is crucial in various fields, including engineering, meteorology, and climate science. And further research and exploration of freezing water leads to advancements in various industries to improve our understanding of the nature of water. These are M&A citations. Thank you very much.
Now we will give word to SEK Qatar.
Okay, do we start? Health and diseases. So for our presentation, we decided to. We decided to do our presentation on malaria. Why isn't it?
So what is malaria? So malaria is a serious, sometimes fatal illness caused by a parasite transmitted through mosquito bites, especially prevalent in the sub-Saharan Africa region. And it is basically a parasite that enters through the bloodstream and matures in the liver by attaching to red blood cells. The symptoms typically appear within weeks, with fever and chills being the most common, and it can be transmitted from pregnant women to unborn children, blood transfusion and organ transplant, or shared needle usage.
So what are the types of malarial parasites? There are hundreds of different types of parasites that have been identified, but the most important ones are two: Plasmodium falciparum and Plasmodium vivax. The most dangerous parasites due to their severe complications, high malaria cases, and how resistant they are to drugs and vaccines. Over 400 Anopheles mosquito species exist, with around 40 vector species that transmit the disease. Risk of infection varies based on local mosquito types, season, and the highest risk is during rainy seasons in most tropical countries.
So malaria threat and vulnerability. So malaria affects half of the global population. Most of the vulnerable groups include infants, children under 5, and pregnant women, and HIV/AIDS patients. Migrants, mobile communities, and travelers with no partial immunity or chemopreventative medications are also at risk. Partial immunity reduces malaria infection severity, but it doesn't guarantee complete protection. The majority of malaria deaths in Africa occur in younger people, as previously mentioned, and all age groups are at risk in areas with minimal transmission and low immunity.
So what are the symptoms? Fever, chills, general feeling of discomfort, headaches, nausea, vomiting, diarrhea, abdominal pain, muscle joint or joint pain, Fatigue, rapid breathing, rapid heart rate, and cough are all symptoms that come together to identify malaria. While they are symptoms of other diseases as well, when all of these are in combination, it's very evident what the diagnosis could be.
So finding the vaccine, during the Vietnam War in 1967, Tu Yu, a Chinese scientist, and her team discovered an ancient Chinese remedy for malaria. The Project 523, was initiated by China to aid Vietnam in finding a cure for malaria. Despite testing around 240,000 compounds on mice infected with malaria, none worked.
Tu recognized that the herb xinghao, or sweet wormwood, was most noticeable in effect. She revised old scriptures and medical texts, introducing an ether solution to extract active compounds from the wormwood. The active compounds, called artemisinin, interact with the parasites, causing them to tear cells apart. The WHO recommends the use of artemisinin in combination with other drugs to defend against malaria almost 2 decades after her findings. So controlling malaria. Annually, 200 million malaria cases occur, resulting in 500,000 deaths, and over 90% of malaria deaths occur in sub-Saharan Africa, as mentioned before. Controlling malaria in Africa is very difficult due to the presence of effective malaria vectors, Aphelis gambiae, Aphelis nestus, and Plasmodium falciparum. Advances in malaria control include insecticide-treated nets, malaria rapid diagnostic tests, and artemisinin-based combinations and therapies. But despite these advancements, malaria remains a global threat due to poverty, human movement, resistance, and climate change.
So the effect of malaria in Africa is a result of poverty and lack of healthcare workers. Africa has 2.3 health workers per 100 treatments compared to 24.8 in America, which is a drastic difference. Malaria diagnosis requires microcopy confirmation before drug prescription, and poverty leads to increased reliance on unqualified medicine sellers, leading to dangerous practices like aspirin. The continent's growing population and travel distances further spread malaria. Despite vaccines and treatments, malaria has highly adaptable vectors and parasites. The use of insecticides in the sub-Saharan region reduces the effectiveness of strategies to suppress vectors.
The death toll. Malaria deaths in Africa from 2010 to 2020, and deaths fluctuating in death rates reflect ongoing challenges of controlling malaria. In 2020, there was an unexpected increase in malaria deaths due to the COVID pandemic. The pandemic weakened health systems. It disrupted routine services, leading to resource realignment, strained health facilities, and reduced coverage.
Lockdowns, curfews, and transportation disruptions exacerbated access to healthcare. The pandemic's external shock may have contributed to the 2020 increase in reported deaths, and data emphasizes the need for understanding external contextual factors and the complex interactions between crises and malaria control efforts.
Estimated cases. Malaria cases increased steadily, reaching a new peak in 2021 since 2014. Factors contributing to this increase include public attitudes and practices towards preventive measures, barriers to the use of insecticide-treated nets in Ikere local governments in the area of Nigeria include ventilation, heat, and discomfort. Sociocultural factors may contribute to suboptimal implementations of preventive measures, increasing malaria cases.
Understanding and addressing these cultural dynamics is crucial for comprehensive malaria control. Targeted interventions considering local beliefs, customs, and challenges are needed. A nuanced, culturally sensitive approach to malaria control is very much needed.
Thank you.
I stopped the share button.
Okay.
Okay, now I'll be talking about dangerous forces and how physics can be applied in real life. As in mass in motion. Momentum depends on the mass and the velocity of an object. Heavy objects moving at a high speed have a large momentum, while light objects moving at a slow speed have a small momentum. To stop a moving object, force is necessary. Greater momentum demands a stronger force. A large force can be delivered in a short time. Force can act over a long time. Force changes an object's momentum. So now I'll be talking about the relation between speed of collision in relation to the chance of death. The stronger the collision, the more likely it is for one to die due to the force being distributed in a shorter amount of time. If, for example, the speed of collision is 32 kilometers per hour, the chance of surviving is 90%. If the speed of collision is 64 kilometers per hour, the chance of surviving is 10%. These data refer to speed of a car when it hits a pedestrian, not in general. The force, there's different types of forces applied in a car. When a car is in motion, various forces act upon it. These forces include propulsion from the engine's resistance from the air drag and friction between the tires and the road surface. Additionally, during braking, a force opposite to the direction of the motion is exerted to slow down the car. There's other forces that act upon the car, such as thrust, which is the one that's going forward, drag force going like against the car, and weight, which is pushing it down, which is the mass. And now I'll be talking about different components that the car has that prevent from the passenger from being more hurt than needed. For example, airbags. Airbags protect car occupants by rapidly inflating during collision, increasing the time in which a car force is applied, thus reducing the force exerted on the occupants, according to the impulse momentum theorem. This extended duration of force decreases the rate of change of momentum for the occupants, minimizing the risk of injury. These airbags basically distribute the force over a larger area, decreasing how much the passenger gets hurt. Next, we have steel barrier and car doors. Steel barrier and car doors do not bend upon impact, effectively absorbing and distributing the force generated during the collision, thereby reducing the momentum transferred to the occupants. This helps them minimizing the impulse experience, preventing intrusion into the passenger's compartment, thus enhancing the overall safety. This feature is a lot similar to the steel cage, which we will cover next. Like I said, steel cage, otherwise known as roll cage. The steel cage surrounding the passenger's compartment serves as a crucial safety feature by maintaining its shape during the crash, thereby minimizing the transfer of the momentum and impulse to the occupant. This stability helps reduce the force experienced by the passenger, significantly enhancing the protection of the event of collision. There are different types of steel in the car, each different strength, thereby serving a different purpose. As seen in the image, the different types of steels have different types of strengths which serve their purpose, which we will later cover in crumple zones. So next, seatbelts. Seatbelts protect the car occupants by increasing the time in which a person's momentum changes during the collision, thereby reducing the force experienced by the body. This increase in time reduces the impulse or change in momentum exerted to the body, lowering the risk of injury, fatality. About 50% of people who die in car crashes do not wear seatbelts. So please remember to wear seatbelts. Next, like I mentioned, we will have crumple zones. Crumple zones are a special type of steel that bends upon impact. These zones are particularly weak spots in the car body designed to fold and absorb in the collision impacts, distributing the majority of the area throughout the various zones rather than on the passengers. This absorption lessens the impact of the force experienced by the passengers, even though the lower forces are exerted for a longer period of time. The passengers survive them. The next, more on crumple zones reduce the force acting on passengers per mentioned. The crumple zones also increase the time in which it's taken for the vehicle to stop, which decreases the force applied on the passenger. This can also be seen in Newton's second law, force equals mass multiplied by acceleration, which supports the way that crumple zones work. Thank you so much for listening. I hope you enjoyed.
Now we're gonna give the word to Sekel Castillo, so come up to the stage. Solo hay 2 micrófonos, que lo sepáis. Y esto es para cambiar las diapositivas. Suerte.
Hello, can everybody hear? Good morning, everybody in the audience. We're a group comprised of Gonzalo, Volodymyr, Stefan, and Zambo. And me, of course, Alban. Today, we're going to present our project dealing with projectile motion of golf trajectory. First of all, we need to ask the question, what is projectile motion?
Projectile motion is when you're going to throw object into the air, and that motion is referred like a projectile motion. That motion is slightly affected by gravity and air resistance. Projectile motion can be 2 types. 2-dimensionals that can be affected by gravity and air resistance, and 3-dimensional when wind and rotation spin is going to be affected. Projectile trajectory is the curving route that an object is going to take when it's going to be thrown into the air and is going to form an angle to the horizontal.
Now, why did we choose projectile motion? We specifically chose this topic because we wanted to create an experiment with many real-life applications. So dealing with the study of throwing objects, for example, or falling objects. When we were sure that we wanted to study the concept of projectile motion, then we needed an example of it in real life that we could analyze. In our case, we chose a relatively simple example, which is throwing a golf ball in an open field, because it was something that we could easily record and analyze using a software. Furthermore, we decided to conduct research on projectile motion, more particularly studying uniformly accelerated motion, and, of course, conducting research on the tracker that we were going to use to develop this project. It's also worth noting that the hypothesis for this project was if only the uniformly accelerated motion formulas are used to analyze the motion of a golf ball, then it will differ slightly from the practical approach, the practical results of this experiment, because there are external environmental factors affecting the motion of the ball.
Okay, to do this project, we need like several materials, like we need 1 standard golf ball, like 1 standard golf pads, 1 mobile phone with camera, and also we need 1 computer. Like we have 5 steps to do this. The first step, first we have to launch the golf ball into the air and using a golf pads. Second, we have to install the tracker app for video analysis. Third, we have to process the video, mark the ball's position in each frame, establish a reference distance, and select the coordinates axis to define position O, and determine the values of X and Y. Next, we have to verify the accuracy of frame making by examining the parabolic shape of graph generated by the app. At last, we export X and Y values, as well as velocities and accelerations per frame for further analysis.
Now, when we had recorded all the video, we had to process the data. For it, we used ULM and UALM formulas. The ULM formulas we used was X equals original X plus V times T. We used this formula to detect the extent distance. After, we used the UALM formula, Y equals original Y plus original V times T plus 1/2 of AT squared to detect the Y position, so the height. When we had calculated all these distances, we created a graph, as you can see, and we could see several characteristics.
First of all, the most notable characteristic of this graph is that the theoretical approach doesn't quite match with the practical approach. More specifically, the practical approach sort of falls short of the theoretical approach around 2 seconds earlier. Now, this can be attributed to the oversight of a very important factor, Drag force, also known as air resistance. When a ball is thrown into the air, or any object, it experiences a drag force contrary to the direction of movement, which in this case made the ball fall earlier than expected with our uniformly accelerated motion formulas. Also, there are several unconsidered factors, such as the specific aerodynamics of the ball, the wind conditions, the spin rate of the ball, as well as the wind velocity that we did not account for, and therefore made the ball's motion increasingly unpredictable.
Projectile motion have application in a lot of fields, for example, sport, military, and video games. I'm going to take basketball for this example. When the player is going to throw the ball to the rim, it's going to make an arc, and that ball is going to reach the max point, and then it's going to go down. It's the same thing like in football, when you're going to shoot the ball into the air. It's going to go down. In military, projectile motion is used to calculate the rockets when it's going to land on some planets, or when they're going to prepare the launch. In video games, projectile motion is used to create a real projectile motion for that video games.
Now, similarly to Dr. Vicente Timón, we also share this interest for exploring the universe, and we wanted to explore how the projectile motion varies from each celestial body. So, for example, in 1971, NASA astronaut Alan Shepard, who was the Apollo 14 commander, played golf on the moon. He carried a golf ball, and using a tool similar to a golf bat, he launched the ball. Now, since the moon has less air resistance and less gravity, the balls travel much faster and much longer. This was in spite of Shepard's lack of mobility, since he was wearing a spacesuit. His idea invites us to explore how projectile motion varies in different characteristics, and also to know how to apply it in the future when these situations will be more common.
Okay, to this project, we think we have some many points to improve our project. Like, first, we can take into account the aspects we omitted in our calculations, like the ball's aerodynamics, spin, and the air resistance. Also, we can extend a spherical approach to cover hypothetical situations with different gravities, air resistance, and so on. Then we have to make sure that the video is completely horizontal and eventually panned. And also make sure the video is always focused and of high frame pixel quality.
This last point is especially important because we used a digital tool to analyze it. Sometimes the frames were a bit blurry, so we couldn't really locate the position of the ball at a specific point in time, which could affect our results in many ways. Conclusion. In regards to the project, the hypothesis was, in the end, accepted because the practical approach did indeed differ from the theoretical approach due to a variety of external factors. Overall, projectile motion has several applications in real life. However, in order to use it effectively, a certain degree of trial and error must be used. Additionally, there needs to be considerations or generalizations for different conditions, for example, different wind resistances, wind velocities, the aerodynamics of a certain object, etc. Fortunately, a guideline to making effective projectile motion exists in this specific form of theoretical approach. Thus, by analyzing and comparing theory with experiments, one can identify inaccuracies and solve real-world problems with projectile motion.
And throughout this project, we have developed our SEK perfil competencial. First of all, we have used critical and creative thinking. We have had to think and develop our experiments creatively, first of all, because we had to come up with an experiment. We had to think of an idea and then carry out the experiment. We also had to analyze the results, so we also had to think critically. In addition, we have also followed an academic rigor because we have followed the scientific method. This was very important for our experiment to be reproducible and verifiable.
Furthermore, we employed investigative rigor in order to further assess the results of our project, because we wanted to know which factors exactly made this part of the project possible.
Thank you.
Thank you very much for listening to the presentation. Have a great day.
Hello to everyone. Before starting the presentation, I wanted to know how many of these people here practice sport. Don't be shy. And I suppose that you being here means that you're interested in science. Well, the same happens to me. I do a sport, I'm a skier, and I'm a curious person that wanted to carry out an investigation that would be useful for my sport. Well, this is a bit of what I'm talking about. And well, I'm going to talk to you about my experiment. So my experiment consists in a sample of people between 40 and 55 years, which are women, which are 10 women from the Spanish female master ski team. And I wanted to know if implementing a strength workout, they will achieve better results at the races, at the ski races in both disciplines, slalom and giant slalom. Well, the aim, I already told you that. I wanted to know if there is an improvement for these women. And well, the hypothesis is that if these women carried a workout during the whole season, they will achieve better results at the end of the season. For this, I took the results of a first race before implementing the strength workout, and then I continued taking the results of the other races after implementing this strength workout. Well, I had to consider lots of variables in this experiment. Well, the independent variable is the strength workout because it didn't depend on other things, just the woman carrying out this workout. And then the dependent variable, which were the speed on the slalom and giant slalom races, will depend in the strength workout routine. And well, I had to control some things because as this was a bit difficult, I had to control because the races were carried out in different places. I had to control the length of the race, the gates that are from the official regulations of the Spanish Federation. And also I had to control the number of trainings they did per week to ensure they were all under the same physical conditions. And also the age group, which is controlled in the sample, so they were all under the same conditions. This is an example of the training that they did. They did a training 3 times per week. They mostly were centered in the lower body because it's the part that we use the most at skiing. But as we have to be balanced, they carried a workout whole body. Well, the methodology is I took the 10 women and I first took the data from the first race before implementing the strength workout. And I implemented the strength workout and then took the results of another race after 2 months of the strength workout. Then the same process with the next race, and then I calculated the mean speed of these races and the standard deviation to see if there's a change. This is the data that I took. And well, this is the process data, which is the average speed and the standard deviation, which I'm really happy, the results, because they supported my hypothesis. And as we can see, there's a curve that, well, it's more progressive in the disciplines of slalom that it's in giant slalom. This is because in disciplines like slalom, which are more technical, they need this process is slower. And yes, and well, my conclusions with the experiment is that the hypothesis was supported by the data, and that the data that I took was reliable because it was all from the official federation. Some limitations that I had were the meteorological conditions, as this year has not been too good to take the results of the races. I wanted to use more races so the data would be more accurate, but I couldn't. And also the sample size is smaller because there's not too much participants in this category. And for a further investigation, I would like to elongate the period of the races that I took and to calculate the difference in absolute value of the sample that I had with the winner of each race to see if there was a real change in the speed. And that's it. Thank you.
Well, after all that sciencing, I think you may be hungry. So we will take a break from presentations and enjoy a tasty breakfast for 20 minutes. So we will see you again in 20 minutes. Thank you.
Hi everyone, now we're back. After we have gained a little more energy, we're gonna go back with the projects. So we're gonna have SEK Atlántico, Cataluña, Dublín, and we're gonna close the presentations with SEK de Alcampo. Also, one thing about the forms, I don't know if you've noticed, but they don't let you like move to the next section if you haven't answered the previous one, so you can just put a dot and then you can go back once the presentation has happened, because the order is messed up, but it's okay. You just put a dot and then you continue, you answer the ones that we have seen, and then you can go back to the ones that you haven't seen yet, okay? So now we give the word to SEK Atlántico.
La completa, Blanca.
Hola, somos Cristina Müller y Blanca Martín del SEK Atlántico y vamos a hablar de cómo afecta la temperatura del aceite de girasol a la velocidad de la ranciedez oxidativa. Este es el índice que vamos a seguir. Desde siempre se nos ha dicho que freír el aceite lo empeora, haciendo que se ponga malo. No obstante, ¿cuál es la explicación científica para esto? Según lo que hemos investigado, se debe a la oxidación de los aceites grasos del aceite, que esto se conoce como ranciedez oxidativa. Y tras investigar algo más, quisimos analizar los factores que afectan a la velocidad de esta rancidez. Uno de los factores más importantes e influyentes en esta reacción es la temperatura. Escogimos un rango de entre 20 y 60 grados centígrados y empleamos como catalizador el hierro en el aceite. Para poder hacerlo, calculamos el índice de peróxidos del aceite de girasol tras haberlo calentado a diferentes temperaturas durante tiempos de 0 a 3 horas desde que el aceite alcanzase la temperatura esperada. Nuestra pregunta de investigación es ¿cómo afecta la temperatura 20 grados, 30, 40, 50 y 60 del aceite de girasol a la velocidad de la ranciedez oxidativa?
Bueno, entonces primero hay un marco teórico que hay que saber para poder llevar a cabo este experimento. Para empezar, la ranciedez oxidativa es una reacción que tiene lugar de forma natural en los ácidos principalmente saturados, es decir, con doble enlace. Los átomos de oxígeno reaccionan con este doble enlace para dar lugar a peróxidos y hidroperóxidos que luego crean cetonas y aldehídos, que son las clases responsables por el olor y el sabor rancio que adquiere el aceite pues, después de este proceso. A continuación, bueno, como se puede ver, están las reacciones químicas que usaremos en nuestro experimento y que evaluaremos. También hay que tener en cuenta la ecuación de Arrhenius, que nos permitirá predecir y comparar nuestros resultados. Entonces, la ecuación de Arrhenius lo que hace es establecer una relación exponencial entre la temperatura y la velocidad de la ranciedad oxidativa.
Nuestra hipótesis es que habrá una concordancia con la ecuación de Arrhenius y que dará una función exponencial. Nuestras variables, la independiente es la temperatura, la dependiente la velocidad de la ranciedez oxidativa y las controla el catalizador, la superficie de contacto, la exposición a la luz y la concentración de oxígeno. El procedimiento es, en un matraz de Erlenmeyer ponemos 35 mililitros de aceite con 5 gramos de hierro y lo calentamos en el baño termostático. Cuando llega a la temperatura que queremos, sacamos 3 muestras de 2,5 mililitros, a las cuales les añadimos 30 mililitros de una disolución 1,1 de ciclohexano y ácido acético, junto con 0,5 mililitros de una disolución de yoduro de potasio saturado. A esto le añadimos luego 30 mililitros de agua destilada y almidón hasta que el líquido tome un color violáceo. Esto lo vamos a titular con tiosulfato de sodio hasta que tome un color blanquecino.
Bueno, tras haber realizado varias titulaciones, obtuvimos la siguiente tabla de datos y la transformamos estos datos en el índice de peróxidos a través de la fórmula que se muestra aquí, obteniendo así la siguiente gráfica. Entonces, como se puede observar, el índice de peróxidos aumenta linealmente con la temperatura, así como con el tiempo durante el cual la mezcla ha sido mantenida esta. Y esto se puede observar no solo gracias a la gráfica, sino más con las rectas de las líneas. Sin embargo, no es solo el índice de peróxidos que aumenta con la temperatura, sino que también la velocidad
oxidativa, y esto es, pues como se esperaba, exponencial. Entonces, a un ritmo exponencial. Entonces, se ve que esto sucede acorde a la ecuación de Arrhenius, bueno, dejando de lado a un dato un poco anómalo que se desvía de la tendencia general, que es de 40. En efecto, nuestro experimento presenta varias limitaciones, pues el índice de peróxido solo es válido en las etapas iniciales del experimento, la incertidumbre del tiosulfato de sodio utilizado es alta y otros factores que afectan a la rapidez oxidativa, como son el oxígeno presente en el aire, en el ambiente, la luz o la superficie de contacto con el hierro, no han sido completamente controlados. Entonces, como mejoras, proponemos medir el índice de yodo a través del método de Wicks o de Hanus, utilizar intervalos de tiempo mayores para que la incertidumbre o el error sistemático sea proporcionalmente menor, y por último, utilizar un baño termostatizado con agitación, puesto que el oxígeno y la luz son un poco difíciles de controlar. Por último, estaría nuestra ampliación. Entonces, el objetivo inicial de nuestro experimento era intentarlo con diferentes tipos de aceite, pero debido a una falta de tiempo solo lo hicimos con aceite de girasol, que es el más propenso a reaccionar comparado con otros aceites como el aceite de oliva. Entonces, a nosotras nos gustaría, en el caso de repetir este experimento o tener otra ocasión para hacerlo, utilizar otros tipos de aceite y poder comparar. Y eso es todo. Gracias.
Hola, nosotros somos Claudia López y Unai Turnes y os vamos a presentar nuestro proyecto sobre el efecto de diferentes desinfectantes de uso común en la supervivencia de las bacterias de la flora bucal. Decidimos realizar este experimento debido a la pandemia del 2020, en donde vimos que recomendaban utilizar desinfectantes para así no transmitir los microorganismos. Y con este experimento quisimos ver si de verdad tenían una eficacia sobre los microorganismos. Nuestra pregunta de investigación era en qué medida afecta la presencia de desinfectantes, lejía al 5%, fluoruro sódico, alcohol 96 y agua oxigenada al 6%, a la supervivencia de las bacterias de la flora bucal, Streptococcus mutans y Actinomyces sp, cuantificadas a través de una cámara Neubauer en número de bacterias por milímetro cúbico. En esta investigación, la variable independiente era la naturaleza del compuesto desinfectante y la variable dependiente el número de bacterias Streptococcus mutans o Actinomyces por milímetro cúbico. Antes de realizar el experimento, nuestra hipótesis era que, debido a la capacidad oxidativa de la lejía, iba a ser la más de más eficacia, seguida del alcohol 96 y el agua oxigenada, y por último el fluoruro sódico, ya que este no tiene una capacidad oxidativa, sino que una enzima que ralentiza la reproducción de las bacterias.
Para testar los desinfectantes, lo que hicimos fue crear un cultivo en agar en placas de Petri, cultivamos bacterias de la flora bucal y las metimos en la estufa hasta que salían las bacterias. Una vez habían crecido, realizamos un conteo inicial por cámara de Neubauer, como se puede ver en la imagen. Después añadimos los desinfectantes en la misma cantidad todos y volvimos a realizar un conteo a los 15 minutos y otro a las 24 horas. Como se ve en la imagen, en el microscopio, en la cámara de Neubauer. Luego, esos son los datos brutos en los que hicimos 3 repeticiones para cada desinfectante y otras 3 para el grupo de control. Después hicimos un promedio con el coeficiente de variación y al final, con el promedio, sacamos la concentración de la placa a través de la forma de Neubauer. Estos son los datos a los 15 minutos y esto a las 24 horas. Después hicimos una tasa de eliminación. Lo que hicimos fue restar a lo que había al principio, la cantidad de bacterias que había al principio, las que hubo después del tratamiento. Y lo pasamos a un porcentaje, también con el grupo de control. Y estos son los resultados. La lejía y el agua oxigenada fueron los que mayor tasa de eliminación tuvieron, es decir, mataron al mayor porcentaje de bacterias debido a su capacidad oxidativa. Después, el alcohol 96 grados, que a pesar de que funcione por el mismo funcionamiento que los dos anteriores, al estar en una graduación tan alta, se evaporó muy rápido y no le dio tiempo a actuar. Y finalmente, el fluoruro sódico fue el que menos actuó, ya que lo que hace es inactivar una enzima, el metabolismo de la bacteria, que es la nolasa, y no ataca las proteínas de la membrana plasmática. Pues estas son las conclusiones.
Tras realizar el experimento, vimos que teníamos algunos puntos débiles que se podrían haber mejorado para obtener unos resultados más acertados. El primero sería tener en cuenta valores de humedad y pH del medio, ya que estos influyen en la velocidad de reproducción de las bacterias. Además, utilizamos unas disoluciones comerciales, las cuales podían contener unos excipientes antibacterianos que influyesen en la capacidad de desinfección, por lo que tendríamos que haber cogido lejía y fluoruro como sustancias puras. Además, utilizamos un método de conteo manual llamado cámara de Neubauer, por lo que podría estar afectado por el error humano, contando de más o menos colonias. Podríamos haber utilizado otros métodos de conteo como la determinación de peso seco de las células, conteo de cuadrantes o método del número más probable, que son otros métodos automáticos. Además, utilizamos unos medios de cultivo ideales en vez de una superficie real, por lo que las bacterias tenían los nutrientes necesarios para crecer. Y por último, utilizamos únicamente bacterias bucales, por lo que nuestros resultados son extrapolables, pero con aproximaciones.
Algunas posibles ampliaciones que podríamos hacer si quisiéramos ir con el proyecto sería usar bacterias directamente de superficies en lugar de la flora bucal, pues aunque sean más difíciles de cultivar, no tendríamos que extrapolar los datos. Después podríamos probar más desinfectantes para tener un estudio más completo, como podría ser el amoníaco u otros comerciales. Y finalmente podemos estudiar la aplicación de los desinfectantes como prevención en lugar de tratamiento. Este proyecto nos ha aportado muchas habilidades, entre ellas las más destacables son las de pensamiento crítico, las científicas y las de comunicación.
Con las habilidades científicas hemos podido redactar un informe e investigar sobre bacterias y la composición de los infectantes.
Después, también hemos trabajado en nuestras habilidades de comunicación, pues este proyecto lo hemos presentado en varias ferias y nos ha ayudado a exponer nuestros resultados, procedimientos y razonamientos. Y además hemos desarrollado habilidades de pensamiento crítico al tener que analizar los resultados, ver posibles errores y analizar las técnicas que vamos a usar.
After the presentations from SEK Atlántico, we will continue in contact with SEK Catalunya.
Hello everyone, we are Gelu, Nadia, and Noah. And we are gonna experimentally determine the constant value of R by using the gas law, ideal gas law. However, to first, so that you understand, ideal gases are theoretical gases, meaning that it's not a real gas, but a mathematical point with no volume, and there are no interaction or intermolecular forces between them. The ideal gas can be written as the equation can be written as PV is equal to nRT, where P is pressure with international units pascals. B is the volume of the gas that can be that is like in liters, N is the number of moles in moles. T is the temperature in Kelvin, and R is the constant value that can be expressed in different units. However, we are focusing our experiment in the 0.082 one, which is in atmosphere, liters, moles, and Kelvin. Our hypothesis states that if we measure the value of all the variables that we mentioned earlier, pressure, temperature, volume, and the moles of the gas, then we will be able to calculate the constant value of R, because the scientific formula of ideal gas states that PV is equal to nRT. Therefore, by isolating R, we will get that the constant R is equal to the pressure times the volume divided by the number of moles of the gas times the temperature. Here are some pictures that we took in the lab that you can see the materials and how we did it.
Okay, moving on to the procedure, the first thing we did was measure the initial volume of the gas and then made sure that the water levels in the separation funnel and in the burette were at the same level. Then the magnesium ribbon's mass was measured and written down, folded into a circle and put inside the boiling test tube. A syringe was filled up with 10 milliliters of 5 molar hydrochloric acid in order for the reaction to start and was slowly injected into the test tube while the burette cap was lowered according to the water level in the burette in order to keep pressure at 1 atmosphere. And once the chemical reaction had finished, we put all of the data into the following table. Okay, so firstly, all the data that was collected was converted into the international standard units, excluding the pressure which we kept at atmospheres. So the volume we measured in milliliters, and we had to convert it to liters in order to apply it to the formula. The same with the temperature. The temperature we measured in Celsius and had to be converted into Kelvin. And then for the number of moles, we first had to balance the equation, and then by using stoichiometry, we got the moles of magnesium, and then using those ratios, we get the moles of hydrogen. And then for the constant R, we take all of the values from before and applied it to the formula.
So our hypothesis was correct despite the percentage of error, because by doing the experiment, we got all of the variables that we were intending to find. So the pressure, the temperature, volume of the gas, and the moles of magnesium. And that allowed us to calculate the constant of R, therefore proving our hypothesis correct, that the R does in fact depend on all of the other variables of the equation. And we think that the reason for our final value of R was wrong and lower than what we had expected was due to 3 main reasons that all have to do something with the materials that had affected our method. However, overall, our method was correct. So the first thing was the pressure. During the experiment, we had assumed that we were keeping the pressure at 1 atmosphere. However, if we were to do the experiment again, we would use a barometer that could help us to be more accurate with our calculations. Second of all, it's the temperature. As mentioned before, we had calculated that we had took the temperature of the gas indirectly through the water, which is once again an assumption that both of these had the exact same temperature. And lastly, in order for us to improve for the next time, we could have repeated our experiment 5 times instead of just 1 in order to get a more precise answers. And as you can see, we had minus 65.5% of errors due to accuracy, which is basically just the number of difference between the value of the R that we were intending to find, which is 0.082, and the one that we had found, which was 0.028. In conclusion, we reached our objective of calculating the average value of the gas constant R by using gas laws. However, if we were to do the experiment again, we would improve our materials and some of our methods. Thank you. And this is our bibliography. Okay, hello, my name is Victoria Gomez-Rose, and I am from SEK Catalonia University P, and I will be presenting my internal assessment for Environmental Systems and Societies class. For my internal, I chose to assess the impact of microplastics on an aquatic ecosystem and remediation strategies to remove these microplastics. I chose this topic as microplastics are a growing concern in all the beaches all over the world. These microplastics are a very large health hazard for animals that end up consuming them. As I live in Barcelona, I wanted to be able to see different ways we can remove the microplastics to try to prevent this issue. For my experiment, my independent variable is the remediation techniques to remove the microplastics, as that is what I will be measuring. My dependent variable is the amount of microplastics remaining, as that is what I'm measuring. And finally, my control variable is the setup of the tank, like the size of the tank and the initial microplastic concentration. My hypothesis primarily states that the filtering strategy
will be the most effective as it is designed to capture small particles, while the other methods will not fully eliminate the microplastics. My materials include a fish tank in water, the phytoplankton, which is Daphnia magna, microplastics, aquatic plants such as water lettuce, a surface skimmer, and a gravel vacuum. Now, when doing my experiment, I have to consider some ethical consideration. As the project requires working with living organisms, such as plants and phytoplankton, this lab cannot be designed to harm those organisms, with excess amounts of microplastics being introduced. And as we're currently in a drought in Barcelona, using too much water can be seen as unethical, and I cannot be wasting this water. During the lab, I also have to consider some safety precautions, like always being supervised and wearing a lab coat. My method includes using each of the techniques 5 times outside of the tank in 1 liter of water. And then after repeating all the techniques 5 separate times, I will see which one is the most effective and apply it to the full fish tank. My first strategy will be installing a filter media made to capture small particles, including microplastics from the water. This filter media works on its own, but it can be clogged if large particles get suctioned in and won't work as effectively. My second strategy will be conducting regular water changes, which basically means to clean out the water constantly to help remove accumulated microplastics and debris from the tank. I will then use a gravel vacuum to remove excess debris from the tank during the water changes. This can be effective in a small area such as a fish tank, but when implemented to a large body of water, it is not possible. My third strategy will be to use a surface skimmer, which removes floating particles, including microplastics, from the surface of the water, and then it sinks to the bottom of the water, meaning they do not collect the accumulated microplastics from the bottom of the water. Then I will be introducing aquatic plants such as water lettuce, water hyacinth, or hornwort to the tank. These plants can be useful removing microplastics as they absorb nutrients and contaminants from the water as they grow. Although they can only take as much pollutants as big they are, so if they do not get fully grown, they will not be able to absorb all of the microplastics. Finally, I will be using a control technique to see if there are any changes in the level of microplastics in the water. This is my bibliography, and as I haven't completed the experiment yet, I don't know the results, but this is my idea that I have been exploring, and basing off of my hypothesis, I think that the filtering method will be the most effective, and this experiment will be completed later this year. Thank you.
Thank you, SEK Catalunya, for your wonderful interventions. And now we're going to give the word to SEK Dublin.
Hello everyone, we're Sehan and Nona, and we investigated the influence on urban runoff on biological oxygen demand, BOD, in the River Liffey, which is located in the middle of Dublin city centre and flows through counties Dublin, Wicklow and Kildare. And we measured the biological oxygen demand using the Winkler method.
Dissolved oxygen in water determines the contamination of water, and it's very crucial for assessing the water quality, the aquatic life, and reflects the overall health of the water body. The technique used to measure the concentration of the dissolved oxygen water sample is the Winkler method. It determines the amount of dissolved oxygen required for biologically decomposed the organic matter in water sample over a set period of 5 days. Polluted water with high BOD means the restoration of oxygen may not be able to sustain the aquatic life.
Water samples were collected in a completely filled bottle to exclude any air. The points of the collection can be seen in the picture, where point 1 is the closest to the urban runoff source. The distance between the points is approximately 1 kilometer.
As we know, the oxygen content of the water sample is fixed
We can measure it by adding magnets, producing a pale brown color. The sample is then acidified and reacts with the excess of potassium iodide. The iodide will react with the oxygen in the water sample and oxidize into iodine. The amount of iodine produced can then be determined by titration with sodium trisulfate solution is added. When starch indicators are used, it can show the end point of the titration, which the color changes from dark blue to colorless, symbolizing the end of the reaction. This is a real example of how the color changes throughout the process of the reaction.
Data collected revealed a noticeable improvement in water quality, increased DO levels as the distance from the runoff source increased. This trend was consistent across all testing locations from day 1 to day 5 of the study. The highest DO concentration was observed at location 5, furthest from Dublin city centre. BOD values calculated by subtracting the concentration of oxygen at day 1 minus day 5 also indicated a decrease in organic pollution level with increased distance.
This study validates our hypothesis about the water quality in terms of dissolved oxygen levels and BOD values is enhanced with the distance from the urban runoff sources. This finding emphasized the necessity of managing urban runoff and pollutants to protect our river ecosystem. Further research can be expanded on identifying specific pollution sources and the effectiveness of pollution control measures.
Minimizing independent variables such as the environment and container in which samples are stored, and controlling the depth and location during water intake will make the experiment more accurate and free from interruption by external factors. Thank you for listening.
Good morning, everyone. We are Javier Delgado and Tassilo Fundulos from SEK Dublin International School, and we are going to talk about our experiment, the impact of the wing surface area on the glider flight.
So before talking about our project, we would like to give a brief overview of background information. So a plane flies thanks to the surface area of the wing, which generates a high lift force, which makes the plane fly. In our project, we are changing the surface area of the wing, which creates a high drag force in the air and makes the plane fly further. According to Bernoulli's principle, an increase in velocity of the fluid, in this case air, occurs simultaneously with a decrease in air pressure. So as this principle says, pressure is lower at the top of the wing since it's longer. And at the bottom of the wing, the air must cover a smaller distance, resulting a higher pressure, as we can see in the picture of the presentation.
So our hypothesis states that if we change the wing surface area of the plane, the horizontal displacement covered by the plane would increase. We thought this would be the case because due to the drag force, the plane would cover a greater distance. Now I'm going to talk about the variables of our experiment. So for the independent variable, the variable that we change, we have the surface area of the wing. The dependent variable, the one that we measure, is the horizontal distance covered of the plane. For the control variables, the one that needs to stay the same throughout the experiment, we have the air density, the angle at which we launch a plane, and the speed in which we launch the plane. These need to be controlled because if not, the results could have discrepancies.
For the experiment, we've used 5 different wing surface areas, and we made 5 trials for each surface area. We took the modifying plane with a wing surface area of 54.18 centimeters square, and we made 2 modifications for smaller wings and 2 modifications for bigger wings. As we can see in the graph, the point where we have the biggest horizontal displacement is in the wing surface area of the modifying plane. So we can say that the optimal wing surface area for this plane is 54.18 centimeters squared. And if we decrease or increase this value, we can also see a decrease in the distance covered.
Concluding, we can say that our strengths in the procedure of this experiment were the identification of the problems, for example, the launch prototype. Another strength were the measurements we took and the manipulation of the surface area of the wings. Our weaknesses in the procedure were that we had problems with the launch prototypes, and we also struggled with our time management.
With regards to the future improvements, we could have better plan for about time management, as well working on a more consistent launcher. For the future, next time, we should focus on improving the plane prototype design to avoid problems related to instability, and also calculating the center of masses of the unmodifying planes using more accurate mathematical tools to keep the planes in balance.
Thank you for listening to our presentation. We hope that you learned something new and found that it was interesting.
Well, after SEK Dublin, we will leave the word to SEK Ciudad Campo. So come to the stage and dos micros aquí.
Okay, have you ever wondered sometime how fast a living organism can produce or consume energy in order to function? Well, this is called the metabolic rate.
Metabolic rate happens in all living organisms, such as humans, plants, animals, and even bacteria.
Hi, we are Marta Benafuentes and Emma Gabriels, and we are first of DP students, and we are here today to present you our metabolic rate machine.
For this experiment, we were given the instructions to make a metabolic rate machine. This was the only thing they gave us, so we had free range of creativity to create whatever we wanted to do.
After extensive research, we found out that the best living organism to use in order to investigate the metabolic rate were plants. This is because plants experience both cellular respiration and photosynthesis, which includes the use and production of CO2, oxygen, and glucose in order for them to survive, and also to produce oxygen so us humans and animals can breathe.
Our idea was to design an experimental setup where we could measure the CO2 absorbed in a 20-minute time period. However, this wasn't our whole investigation. We also decided to include different light wave exposures, which were red, white, and blue.
Our initial hypothesis after searching for background information was that blue light wavelength will result in the most efficient light for plants. This is because it would generate that the plant absorb a higher amount of CO2, so indeed they increase their metabolic rate. This is because blue light is highly absorbed by chlorophyll A and B, which are pigments found in plants, that will create that the plant will absorb these levels of CO2 due to the photosynthetic spectrum of isolated chloroplasts and intact leaves.
So this is our machine, and it consists of a cardboard box with the objective of reflecting and absorbing any unexpected light that could affect the results.
So as you can see, the inner container consists of a transparent cylinder closed by a lid, and this lid has a small hole in it so we could be able to introduce the mouthpiece of a CO2 sensor in order to measure the CO2 levels inside our new environment. We also furthermore include a small hole, more or less as the size of our lamp, so all the light created by the lamp will go just directly to the plant, and also to avoid any unexpected light from the environment to go inside the box and change our results.
So in order to do this experiment, we had to go through a specific process. We first took the cardboard box and placed black poster paper on the outside so any light would just get absorbed and not go into the plant. Then on the inside, we put white poster paper so all the light would reflect off it and just go into the plant. Then after creating the box, we took the plant and put it in a container with soil, watered it, and placed it next to a light for 1 day so it would settle into its new environment. After waiting for 1 day, the testing part of the experiment began. We placed the container inside of the box and placed the CO2 sensor with plastilin around it so there weren't any spaces so that air could not enter nor exit. We then placed the lamp in the hole that was made and turned it on, while simultaneously starting to record the CO2 absorption. Since we had to do 3 different colors, we started off with the white light, then moved on to the red light, which we created by placing transparent red paper on the lamp, and then lastly with the blue light. We chose blue, red, and white light since blue and red are on the edges of the visible light spectrum, so they are the maximum and the minimum light wavelengths. And white reflects all visible light. And then lastly, we didn't choose green nor yellow since plants don't absorb those colors, which is why they are the color.
So here you can see the results we got after measuring all the CO2 levels so the table represents the metabolic rate to its corresponding wavelength light. So we made it by getting the measurements in each trial and making an average so we could get a more precise result, and then dividing it by the time of exposure to light, which in our case was 20 minutes, and we got the metabolic rate. As these results were in parts per meter units, we transformed it into moles so we can have all our data in international system of units.
So here we can see the graph which visually represents the results. We can see how the blue has the highest metabolic rate, followed by the red, which comes in very closely, and lastly the white, which has the lowest metabolic rate.
So after conducting the experiment and processing all the data, we can confirm that our initial hypothesis was correct. We observed that blue light created the plant to absorb a higher amount of CO2 and indeed to increase their metabolic rate. It was very closely by the red that absorbed less than the blue light, and lastly the white with the least amount of CO2 absorbed. We also see that our initial research question was whether different light colors will affect the metabolic rate. And although the results showed that the difference weren't significant, the blue light is the most effective light for crop production, and as it will generate the plant to quicker their processes or metabolic processes. As we said before, they were cellular respiration and photosynthesis. However, although we found out and conclude that blue light were the most efficient light for plants, it is not the best or optimal option for crop production. This is due to its higher cost and difficulty to use. So therefore, sunlight, which is a free, natural, and renewable source, is still the best option for cultivating plants. So in conclusion, our experiments demonstrates that although we have different colors that can affect the metabolic processes of plants, blue light is still the most effective, as these wavelengths create the plant to have a higher absorbance of CO2 and to produce quicker oxygen for us humans.
So during this experiment, not only did we learn how metabolic rate works, but we also learned how to work collectively with other people and to use this as a practice for bigger projects such as our internal assessments in the IB program.
We are also very grateful for the help we receive for our teachers, scientific coordinators, and lab technicians who helped us to achieve the best results, and also from who we learn new things. Thank you.
Thank you very much.
Good morning, my name is Carla Hidalgo, and today I'm coming here with my colleague Winnie Sun to talk about our experiment, which consists of extracting the DNA from fruits. Firstly, before carrying out our experiment, we did a brief introduction talking about our objective, the hypothesis, and the variables, and then we did a further research to know more about the topic we were going to be studying. This is our index.
Okay, so firstly with the objective of this experiment. The objective of our experiment was to find out if the type of fruit and the temperature had any relations with the amount of DNA extracted from the fruit.
Our hypothesis is that the temperature and the type of fruit will have an effect on the extraction of DNA. The higher the temperature, the more DNA that would be extracted due to thermal expansion and thermal contraction, which states that the higher the temperature, the more volume that would be coming up from the substance exposed to the heat, and vice versa.
Okay, and now with the variables of our experiment. First, there comes the dependent variable, which is the amount of DNA that we are going to be extracting from the fruit, because it's the variable that we will be measuring during the whole experiment. The independent variables, we have two: the temperature, which will be at room temperature at 25 degrees Celsius, at 35 degrees Celsius, and at 45 degrees Celsius. And then our second independent variable is the type of fruit. We will be using bananas and oranges. And our two control variables will be the type of filter that we use to extract the DNA and the times that we are going to repeat this process.
Then our research. First, we need to explain what is DNA. All living things contain genetic information known as DNA, which is deoxyribonucleic acid. DNA, along with RNA, are nucleic acids commonly found in the nucleus. These macromolecules provide the basic instructions our organism needs in order to function correctly and to grow and to develop. And apart from that, DNA consists of a double helix structure because it is two strands twisted together. Then, the good question: why did we choose oranges and bananas? The answer to this question is really simple. Basically, these fruits contain a relatively high DNA content per cell. The DNA content varies among different fruits. However, in the case of oranges and bananas, they had a really high content in comparison with other fruits belonging to other plant species, which made the extraction process much more easier. Apart from that, they were also relatively cheap and available in the supermarket. Then, the DNA extraction and its methods. DNA extraction is a laboratory technique used to isolate DNA from other cells or tissues. It involves breaking open the cells in order to separate the DNA from other cellular components. And once we have the DNA separated, we can now use it for analysis or for other applications such as genetic research or other things. Then, the DNA extraction involves three main methods. Firstly, the cell dissolution, where the cells are treated with a lysis buffer or detergent, in our case, in order to basically separate the DNA from other cellular components. Then we have the precipitation, where the alcohol is added to the sample in order to, for the DNA to precipitate out of the solution and extracted. And finally, the purification, where the DNA we've extracted from the precipitation comes here and we've washed it in order to remove any impurities or contaminants.
Now we're going to talk about the methodology of this experiment. So here on the left-hand side of the screen, you can see all the materials that we've used during the whole experiment. And now I'm going to talk about the steps that we took to do this experiment. So first of all, before starting the actual experiment, what we did was to set up the laboratory water baths, respectively to 35 degrees Celsius and another one to 45 degrees Celsius. And then what we did was to measure 30 grams of banana and 12 milliliters of diluted water into a mortar, and then using a pestle to make a homogeneous mixture. Our second mixture was the detergent mixture, which contained 10 grams of detergent, 10 grams of diluted water, and 2 grams of salt. And after we mixed that all together, we took 11 grams of the detergent mixture and put it into the banana mixture. And finally, we set up the test tubes with our racks, and we put a filter in on top of the test tubes with the mixture, and then we waited until 2 milliliters of the product dropped down, added about 6 milliliters of ethanol alcohol so that the lipids of the fruit could dissolve the cell and leave just the DNA, leaving our final results.
These are our final results, and you can see in this slide and in the next one, we've done it with the two different fruits at 3 different temperatures that were the room temperature, 35 degrees and 45 degrees, and doing 3 different repetitions per temperature.
Okay, so taking into account our experiment, our hypothesis that Carla said earlier was correct. there is a correlation between the temperature, the type of fruit, and the extraction of DNA. However, since this experiment is a qualitative experiment, we are not able to measure exactly how much DNA has dropped. However, we can eyeball it.
Throughout the experiment, not everything came up as we expected. As you can see in the results from the oranges, in P4, P5, and P6, we faced some anomalous results. Later on, we found out that one of our filters had broken, and this had led in our changes in DNA. Apart from that, we've also discovered that it was much more difficult to extract the DNA from oranges since they are made mostly by water, and most of the fiber didn't filter. Thank you.
Thank you very much.
Bueno, esto lo dejamos. Sí.
Well, that was so interesting, and we were captivated by your creative ideas. Thank you all for your hard work in elaborating these fantastic projects that have enriched our minds with knowledge. Moving on, a roundtable has been organized in this space. We will be joined by students and coordinators from the science department to discuss diverse and very significant topics.
So now I'm going to explain what the dynamics of this roundtable is going to be. So we're going to have two students, one from SEK del Campo and Sen Castillo, physically here with Dr. Vicente, and then we're going to have students online too. So I'm going to propose 3 questions that each student and the scientist is going to answer, and then afterwards we're going to propose a round of questions that you can ask Dr. Vicente. So we're going to start. So I call the speakers from the schools to come to the stage. Sí, sí. So I'm going to propose 3 questions. The first question is going to go to Alborán, Bahrain, and Qatar. The second to Castillo, Atlántico, Catalunya. And the third to Dublín and Ciudad del Campo. And you're invited to answer each one of them if you want to intervene to give your professional opinion. Okay?
Okay.
So the first question is, in what ways do you see artificial intelligence impacting scientific research and discovery in fields such as biology, chemistry, or physics? So this question is to Alborán, Bahrain, and Qatar. So what do you think, Alborán?
I think so. Can you hear me?
Yes.
Okay. So in my eyes, artificial intelligence can be used in many different ways, but mainly for realizing and doing really repetitive and complex activities that for humans would be very difficult, such as the analysis of the analysis of an animal genome, or for example, the simulation of drugs. Nonetheless, all these all these activities, I think they might be regulated and controlled by human intervention, because artificial intelligence, like, it can also fail, and we cannot rely just on this activity and this and this tool to these activities. In fact, for example, artificial intelligence can be used to solve and to try to deal with genetic diseases, because it can analyze, as I said, the genome that is very complex still for nowadays for scientists.
Thank you for your intervention. Now I give the word to Bahrain. So what's your perspective on this question?
So hello all. I believe that to everything, there is a good and bad side. It's just about how it's used. AI is a powerful tool that can be used to generate long, extended answers fast. AI gives answers broadly, yet still accurately. This makes it useful in many ways. However, that does not mean it should be used to simply give answers to any question or do your homework and assignments instead of you. But I have to admit, I have done it once or twice. There are some pros and cons to AI. There is accelerated data analysis and pattern recognition. AI algorithms can process large volumes quickly. It can uncover hidden patterns and correlations, and it expedites scientific discovery and leads to new insights. Automation and increased efficiency. By automating repetitive tasks like data pre-processing and simulations, AI allows scientists to focus on complex aspects of research, improving overall efficiency and productivity. It can also help with hypothesis generation optimization and helps with drug discovery and development. However, I don't want to go too long on that. Cons of AI are like lack of transparency and interpretability. Complex AI models such as deep neural network can be challenging to interpret. It can limit scientists to understand the reasoning behind the AI's results. There is sometimes data bias and quality issues and ethical considerations, like AI can sometimes use sources that are not trusted and steal the information from sources that are trusted. Now, fun fact, the pros and cons were all written by AI. I didn't try to sing words about the pros and cons, so you guys all basically heard me read something generated by AI. My point is AI is so powerful that it can criticize itself and identify its issues, and I still believe that AI is going to be quintessential to the normal matter of school life. It can be useful to recognize patterns and identify mistakes in research, and it will help us with discovering new ideas in the future. Thank you.
Thank you for your wonderful opinion. And then I'm going to give the word lastly to Qatar. We seem to have trouble connecting, so Dr. Vicente, you want to give your opinion on this?
Well, my opinion is quite simple. Artificial intelligence is a new technology. You remember 2 centuries ago, something similar with the Industrial Revolution and etc. The people in this time said, okay, the machine is going to don't allow us to progress, etc. The machine is going to do the things that the human beings are doing, etc. Now, artificial intelligence, I believe, is something similar. It is a new technology. It's a very good technology. I believe also it has a tricky because it uses very good databases. And of course, the artificial intelligence deals with the databases better than the human beings because it has this capacity. But it has to improve a lot. I'm not afraid. I think it is a good technology that, for example, human being mistakes and then can improve. But near nothing more is human evolution.
Thank you. Now the second question is going to go to SEK Catalunya, Castillo, and Atlántico. And this question is, what are some pressing global challenges that can be addressed through scientific innovation? So Castillo, sorry. So Castillo, what do you think?
Thank you very much. What challenging?
What pressing global challenges?
Yeah. So the question could be much better, what can't? Okay, so I think science innovation is the core of any human development in the last centuries, and in the present time we can face, we can address, and we can hopefully successfully overcome problems such as the global warming, okay, sustainable agriculture, sustainable farming, access to clean water, the let's say, cheap access to renewable sources of power, and also the eradication of diseases. This last one being the more clear, the situation with COVID-19. Okay, so science was able to provide an answer in nearly 1 year. This means we discovered the solution, we tested, we implemented, and we were able to vaccinate all the population in such a short period of time. So it was an excellent response. Again, science and technology is in the really core of the human development. And if we want to transfer to the next generation a world much better than the one that we have found, we have to have resource to that.
Thank you.
Thank you very much to you.
What do you think, SEK Atlántico? Do you agree on that?
We think that currently we have many problems globally in which scientific innovation can be the key to their elimination or reduction. We can associate most of them with the SDGs, and they are the center of action of the 2030 agenda. So, for example, I am sure that the enormous climate crisis that we face comes to mind for all of us, where climate change, which scientists has been warning us for years, is now a reality. This problem, in turn, is closely related to the energy crisis and the sustainability problems that plague the planet, due to the pace of life and level of consumerism in the most developed countries. In this field, science can investigate, for example, more sustainable methods of producing and obtaining energy, but also modification of lifestyles, without forgetting the terrestrial and aquatic ecosystems plagued by pollution, one of the key problems being the need to reduce the impact caused by plastics. In other fields, it is also important to fight inequality and the food crisis, trying to achieve more sustainable food production methods and a more equitable distribution of food, and to develop sanitation systems in developing countries. Science isn't the only one responsible for finding solutions. Without it, when politics, economics, and science come together, important achievements can be achieved in record time, as demonstrated in the development of vaccines during the pandemic. Therefore, we are convinced that if we invest in scientific research, develop joint international cooperation policies, and raise awareness among the population, it is possible to address these problems.
Thank you for your wonderful intervention. Now I give the word to SEK Catalunya.
Hello, I believe that this question can be answered using my internal assessment, as I am addressing the global challenge of microplastics and thus addressing the issue by using the techniques to remove the microplastic accumulation. A larger adopted version of a filter media can be created to be used in larger bodies of water to address microplastic concentration in the aquatic ecosystem. Scientific innovation can be seen as a technocentric perspective, a key term in ESS, which means that it requires the use of technological innovation to be invented, to then address global issues. And these global issues can range from climate change to poverty. Science has become an invaluable tool in helping us tackle some of the most pressing global challenges of our time. By leveraging advances in technology and data analysis, scientists are able to identify patterns and trends that can inform our decisions and policies. One final example can be how we are using sustainable energy such as solar panels or wind energy to use less unsustainable energy. Thank you.
Thank you. Dr. Vicente, do you want to add something to that?
No, it's quite clear what they say. I only perhaps to add that, yes, the human being should think more that we live in a planet. This planet, it has their limits, and then perhaps we must take more care in this planet. They speak about the microplastic and nanoplastic, global warming, etc. But the human beings should think in all of this all together, not to be one part of the humanity in one sense, in another, etc. Yes, no more.
Thank you. And now the third and last question is for SEK Dublin and SEK del Campo, which is how can AI support personalized learning and adaptive educational approaches? So I give the word to SEK Dublin.
Thank you. AI can help students studying. Thank you. AI can help students study in a personalized way, as the students can ask the AI questions about doubts they have on the AI, not restricted by place or time as a teacher may be. In such a way, the students can focus on their weaknesses in a deeper way. This leaves the teachers themselves free to prepare an assignment and correct it, as well as provide feedback to essays or projects. Furthermore, the AI's ability to correct in a quicker way some types of exams helps to pre-clear the assignments, which helps to free up the teacher's time for other non-automatable tasks.
Thank you. And now I give the word to SEK del Campo.
Thank you. So personally, I think that there are many different ways in which artificial intelligence can bring benefits in terms of enhancing and facilitating education. but I think that the most important and noticeable way is with personalized learning. And this is basically that the artificial intelligence offers a student different types of personalized learning, environments and experiences in which these are based in their own preferences, strengths, weaknesses, interests, and so much more. And this way, I think that students can learn in more effective ways and in more entertaining way for themselves and at their own pace. I also think that it can also increase the accessibility of learning to many different students, since with the artificial intelligence you can create new educational tools or references and resources which then us students can later on use for our research, our investigations, and so on. And since, as I said before, it can bring personalized learning, it is open to all types of students, so it doesn't really matter if you have any type of disability or disadvantages in terms of learning, since the artificial intelligence can adapt to you. And even though it has all of these advantages, I think there's also a little disadvantage with it, which is its reliability, since the artificial intelligence is still a new thing that it's currently constantly evolving, and most of its information is based from the internet. It has also, instead of having it has a lot of reliable information, but it also has false information. And therefore, it is not fully reliable. Therefore, I think that it is really useful for using as personalized learning and to basically be able to learn more in your manner, but as long as you use it with caution and taking into consideration its reliability. Thank you.
Thank you. Before giving the word to Dr. Vicente, I wanted to ask Sir Castillo, as you're the teacher here, how do you think that AI has affected this personalized education?
It is already affecting. It is already affecting. We have been, we use as a supporting means several web pages that can add our students in with certain IB questions from past papers, and some of them already incorporate the IA when they address how their answer is correct or incorrect and what the causes are. So the impact, I envisage it, it will be dramatic in positive terms, I mean, but just also agreeing with this table, I think that that's a technology that is in the very early stages. Okay, so we have lots of things to see in the future.
Thank you. And then, Dr. Vicente, what do you think about this?
About this is it's quite tricky because artificial intelligence, yes, it's good for teaching, it's good for education, etc. But what the artificial intelligence can be is, to see you understand me, is it can't be one replacement. Okay, artificial intelligence can help you to learn something, etc., but not to do what you should do. Okay, I need to learn something. Okay, artificial intelligence can help, can be a good help, but not what it's going to do. Understand me, it is the typical, when I was younger, the people that don't wanted to learn something, you remember, they copy in the exams. Now they do chuletas. What I think it is risky of artificial intelligence, maybe the last chuleta. Okay, I don't learn, the artificial intelligence learn. But if not, yes, it's what I told you. It's a technology, quite very good technology, and can help you a lot, but no, it's not the replacement of you.
Thank you. And with this, we're going to finish the round table, and now we're going to start the round of questions. So everyone in the audience can ask any questions to Dr. Vicente and also people online. So are there any questions in the room? Yes? Vale. Gracias.
The question in English or in Spanish?
What you prefer.
Vale, pues en español.
Vale, en español.
Después de tantos años estudiando algo que realmente no era lo que querías al principio, ¿cómo seguiste motivado a a llegar a tu objetivo?
La verdad es que la pregunta es muy bonita, claro que sí. The question she asked me because I have studied several subjects that I didn't like so much. Because I love science. Science is knowledge-man, etc. You don't generate perhaps the knowledge-man that you want, okay, but you know what has been the end, the final. I am doing what I wanted. I am studying the universe, the stars, etc. It's hard. It's hard because you have one idea of science. Wow, it's good. I am going to do that. It's because science, more or less, the subjects are different, but more or less is the same. You have seen in your presentation hypotheses, development, conclusions, etc. The methodology, the scientific method is the same for all the subjects.
Thank you for your question.
Talking about IA, how do you think IA is going to affect how we approach science and scientific research?
Yes, it's affecting. Me, for example, I am using artificial intelligence to a better analysis of the infrared spectra of some celestial bodies. And it's quite good. It's what I tell you. It helps you a lot. And she is able to detect some things that I am not able to see. What I don't want of the artificial intelligence is it replace me. Okay, the artificial intelligence, okay, do all the spectra, etc. And I say, okay, artificial intelligence then learn about infrared spectra. Artificial intelligence is something doing by the human being, and it has also errors, and it commit also mistakes. But yes, in science, for example, you see in medicine it's incredible. For example, for diagnostic, in image, etc., because it's able to see what 2 or 3 doctors are not able to see. We must learn to live together.
Okay, we have one question online, so can you turn her microphone on?
Yep. Es de SEK Cataluña, es en español la pregunta. Para motivar a la juventud, ¿qué consejo les darías para que estudiaran en el ámbito de la ciencia?
I explained in my talk curiosity. I believe all of us are curiosity. Why don't ask when you are reading this letter in red color? Why you don't realize that we are able today to connect here people from here, Dubai, Ireland, etc. Several of these things, today we believe it's common to have a television, it's common to have a mobile, etc. Why we live with these technologies and etc.? Because science, we must be critics, we must to understand, for example, yes, how it works, how it works one mobile, not only to do videos, what I said, to be an influencer, etc. It's because there is a very big science behind, and it's good to know this. And it's good to know, for example, what I did with LEDs, to try to solve for the society these problems. I am now working, for example, in a big problem of the energy storage. Why? Any of us has this capacity, this curiosity to solve these problems that help the humanity to advance. Is my main advice about to become a scientist.
Thank you.
Are there any questions? I have a question for you.
Okay.
I'll do it.
Tell me.
Is there any presentation that you've seen today that they have surprised you, like you didn't expect that level of rigorous research, or didn't meet your expectations this Congress, or not?
Es que, science in my work, for example, yes, for example, the project that we are doing now with these pollutants in the environment that became from the car exhaust, etc. We always thought when we started this research that we are never going to obtain nothing. Nothing because it's something studied, the masks are on the market, etc. And for us, it was a surprise. The activated carbon it's possible to get all of this and is able to protect us, etc. And when we see the physics that is inside is incredible. Or for example, what I explained you in Venus. In Venus, there is a very big discussion. Why phosphine, not phosphine? Phosphine is related with life. There are bacteria in Venus clouds. Okay, when I did these simulations, I was quite surprised with the results. I said, yes, the spectra is quite clear. If there is bacteria, they should see in this peak. Okay. One of my colleagues, I sent to my colleagues, and my colleague said, "Oh, Vicente, wow, it's interesting. I am going to try to fix it." Yeah, I don't know. I am still waiting. And sometimes science fail. I have had in my life, but I don't explain here. Some experiment that was completely, absolutely crazy.
But is it discouraging when you don't get the results that you want? Like, is it a hard career path? Is there many times that you may have felt like, is it like worth it to go through all of this?
Of course, it's the same than Archimedes, Eureka. It's Eureka.
So you encourage all of us to like keep on going?
Yes. But sometimes is the problem. I have had 2 or 3 Eurekas in my life, but for example, with LEDs, sometimes the research cut because the companies get these patents, etc., and then they continue this research. Only I clear you, I am doing basic science. The good thing to do basic science is that you can do what you have in mind. Okay, no science directed to research something. It is the kind of scientist that the society needs. And then, please, to develop your idea, whatever crazy or etc. It seems your idea. In your presentation has been fantastic today. The water in the Dublin River, etc. The plants, for example, it's something that you never realize, but there are a lot of science there.
Okay, thank you. So now we're gonna finish. You have a question. Okay.
One question. Okay.
Vicente, te vamos a hacer una pregunta. Evalúa el Congreso. ¿Qué te ha parecido?
Wow. It's quite. Perhaps I express better in Spanish than in English, but in order to understand the other people. The future of science, of course, is in me, but in me not so much. The future of science is all of you. All of you, all the students that are here in this room and are outside. There are a lot of interest. I believe you believe in science, or no? You are doing science. Then this Congress is fantastic because I see future in science due them. It's necessary to do more of these activities. It is a very good example for other institutions, other college, etc. Because the future of science is in yours. So good. Thank you.
Thank you. With this, we're gonna finish the round table. So thank you all for answering the questions. Very good. I was very impressed, and I think everyone was very impressed with all the answers. So now we're gonna have the closing ceremony, the closing speech that's gonna be given by Maricruz Lagar, which is the General Director of all SEK schools. So I invite her to the stage to give her speech.
Thank you.
Muy bien, muchas gracias. Nada. No te preocupes, me quedo de pie.
Queridos estudiantes, queridos profesores, Elvira, Javier y por supuesto a nuestro científico invitado, el doctor Vicente Timón. Lo hemos pasado muy bien, una presentación muy entretenida y muy divertida, y a todos los presentes. Hoy, al concluir nuestro segundo Congreso Científico, quiero tomar un momento para reflexionar sobre la jornada que hemos compartido. Hemos sido testigos de la curiosidad insaciable la dedicación y el ingenio de nuestros jóvenes científicos, quienes con cada proyecto y experimento nos han demostrado que el futuro de la ciencia está en buenas manos. Cada descubrimiento presentado, cada hipótesis planteada y cada solución innovadora son la prueba de que el espíritu de investigación está más vivo que nunca en la mente de nuestra juventud. Vosotros, queridos estudiantes, sois la promesa de un mañana lleno de avances y de progreso. Cada uno de vosotros tiene un papel muy importante en el futuro de la ciencia. No importa si os convertís en físicos, químicos, biólogos o médicos. Lo importante es que sigáis persiguiendo la verdad y la innovación. La ciencia es un viaje sin fin y vosotros sois los exploradores y no tengáis miedo en pensar a lo grande. Agradezco a todos los que han hecho posible este evento, a los organizadores, a Elvira, por poner ahí todo su corazón y toda su pasión, a los profesores, a la Fundación Felipe Segovia, en la persona de Javier, y, por supuesto, a nuestros estudiantes por su esfuerzo y su pasión. Que este segundo congreso siga siendo el comienzo de un camino lleno de exploración y de éxito. Sigamos adelante con la misma curiosidad y la misma valentía que nos ha traído hasta aquí. Muchas gracias a todos y a cada uno de vosotros por este evento inolvidable y, por supuesto, muchas gracias al equipo de ciencias de todos nuestros colegios. Ha sido una jornada extraordinaria. Hasta la próxima.